we're interested, it seems to be a recurring theme from the talks I've heard, that the important role of assessment and formative assessment, and also the kind of tension that we have between what would be ideal and the kind of resources we actually have available. So I think the talk about mooting made that point very eloquently, that ideally we would allow students a far greater exposure to this opportunity, but the reality is, there are only so many hours in the day, etc., etc. So for that reason, we kind of became quite interested in how much can you automate assessment, and became quite clear fairly early on that there is a danger that the desire to automate assessment results in skewing the assessments. You only administer assessments that are easy to mark automatically. So a good example of that obviously is multiple choice. And there are many other forms of assessment and assessment artifact that don't easily fall into that category. In computer science, but not restricted to computer science, diagrammatic notation is very, very commonplace. We can think of other electronic circuit diagrams, architecture, and many other disciplines. Diagrams also play an important role, but they're quite central to many aspects of computer science. So for that reason, we decided to get involved and have a look at that. 99% of the brain power, the inspiration, the hard work and everything else has come from ambikesh, who's just finishing his PhD in this area. So I think it's far more appropriate that Ambi talks about the detail and hopefully snaffles the glory. So I shall hand over.
Okay, thanks very much. Okay, to start with, special thanks to Martin for supervision and guidance. And I would be happy to receive feedback, so feel free to interrupt if you wish. Okay, so this is the structure of my presentation. I'll talk about the project, what are the outcomes, and then I'll talk about the evaluation results, which we have evaluated on a coursework at Brunel. Okay, I'm a final year PhD student under the supervision of Professor Martin.shepperd, and my area of research is how to mark diagram automatically. I started in September 2005 and I finished PEP last year at Linda. This is the project for which we have got the fund from Curriculum for Innovation Fund 2008-2009, and the main aim of this project is to improve the undergraduate assessment using automated marking. That's what the primary aim of the project is. As previous speakers have already talked about, there are immense benefits of assessment and in specifically providing feedback to students. And generally, automated assessment tend to be more consistent, and then it frees up the lecturer's time so that they can spend on other useful activities. Before I talk about the details of the project, I'll just explain why did we choose diagrams in particular for automated marking. So there are different kinds of courseworks that students submit. One is multiple choice, of course diagrams, and the other bit is the essays. Now if I put it in a hierarchy, then the multiple choice are highly structured, so they are very easy to mark. In fact, the U-Link automatically marks the objective type question. On the other hand, there are essays which are least structured, and they are most difficult to mark because they don't have any structure at all. In between somewhere falls a diagram which have a semi-structure. Of course, they are not as structured as the multiple choice, and they are not as free as essays as well. So they fall somewhere between multiple choice and essays. So that's why we have tried to focus on diagrams. Apart from that, the other reason to choose the diagrams is that diagrams are widely used in computer science domain. That's why we wanted to focus on this a particular piece of coursework which contains diagrams. Now, diagrams are difficult to mark. Why? Because sometimes students submit a diagram which are partially correct. So they are not fully correct. So they are not exactly similar to the correct diagram, but they are partially correct. And the second problem is that much of the meaning of a diagram lies in the labels that have been used in the diagram. But the choice of labels is largely unrestricted, which means students can use whatever label they wish to choose. So just to give you an example, if select recipe is one of the labels in the diagram, then these are the different labels that the students have chosen in the coursework that we have evaluated. So one is select meal recipe, select recipe for the meal. Sometimes they have spelling mistakes, which makes the process of comparison difficult. Sometimes they use synonyms, which are like choose meal instead of select recipe. Similarly, sometimes they use abbreviations and special characters as well, which makes the whole process of marking the diagrams difficult. So this is the fundamental problem that my PhD research deals with, and I have developed a framework to automatically compare the labels in the diagram. And to develop the tool for this project, I have used the framework that I have developed for my thesis and implemented it and then evaluated it on a coursework at Brunel. These are the 4 outcomes for the SIF project. One is we would develop a demonstrator which should automatically mark the diagrams. Second is we would evaluate it on a coursework at Brunel. We will package the results as an open source with user guidance software documentation so that other lecturers can download and use it. And we'll tend to develop a larger research project for external funding. I'll talk about each of these in the subsequent slides and how much work we have done for these. I'll skip this slide because this is the framework that I have developed during my thesis, and it's a bit technical, so I'll skip this and come to the main bigger picture. This again is a bit technical, but the only comment I would like to make here is this tool is customizable and it's extendable and it's plug and play. So users can customize it in ways they feel best. Okay, this is the bigger picture, and this is how the tool works. The first step is the students come and draw a diagram in a tool of their choice. The tool can be AgroUML or NetBeans or whatever tool. NetBeans is currently used by a module at Brunel. So they can choose whatever diagram drawing tool they want to choose. That's the first step. This first step is also taken by the lecturer. So lecturer comes and draws the same diagram, which is the model solution, using the tool. So the first step over, and the second step is then the students uses the diagram assessment tool which has been developed at Brunel, and which gives as output a feedback to the student, which helps students to see where they are lacking and possibly improve. So that's the bigger high level picture of what is going on inside. Okay, this is a diagram drawing tool which has been developed by University of California. This is the tool which we have used for evaluation. So this is just a diagram drawing tool. So students and lecturer come and draw the diagram here. Out here, and I'll just show you this in the next slide. Lecturer needs to mention what are the feedback the student should be getting. Now for each state or each label in the diagram, so for example the diagram has 4 labels: select recipe, assemble ingredients, cook meal, set the table. Now for each label the lecturer mentions what is the positive feedback, what's the negative feedback, and how much marks they should get. So positive feedback means if the label is correct, what should you say to the students as an encouragement or as lead them on to something more complicated. The negative feedback means what should you tell to the students if the label is incorrect, so that they can improve their understanding and redo the coursework. And of course this all is targeted at formative assessment, although for the purpose of evaluation we have evaluated it as summative assessment. the results of